Working with timestamps can be difficult due to a number of different time data formats and resolutions. In this video, we will go over some of the time data formats and structures and operations. By the end of it, you should be able to explain what Unix time, POSIX time, and epoch time is, describe data types for date time, select rows based on timestamps, and sort tables in chronological order. Unix time tracks the progress of time by counting the number of seconds since a specific time instant. That instant is the start of the year 1970 as per UTC time zone. Notice that this is an integer. We need to find a way to convert this to a readable date and time. Date time 64 NS is a general data type for date time. This general data type maps to specific data types called M8 or before M8 or after M8, depending on your machine. Our big task is to convert int64, which was that original instance since 1970 UTC time, into either one of the above date time formats, so Python renders it in a human readable format. It's kind of confusing maybe seeing all these data types, but we can quickly convert a timestamp to Python format using, for example, toDateTime function here. This function simply will convert the input to datetime format to a form that Python understands. And in this case, we'll put that into that parsed time column, which you see is pretty human readable as well. The unit argument is most important here, as it tells the function what the unit of the input is. In this example, the input column is timestamp from the data frame, called tags, and the unit of the input is declared to be seconds. The output is stored in a new column that is named parsed time. Once time is converted to Python format, you can use it to create filters. The filter will select only the rows that will match your criteria. For example, once we build a Boolean filter called greater than t, and in this case, make that timestamp to be after 2015, February 1 or 021, we can use this filter to select only the cells in the data frame that are true for this condition. We can also leverage the timestamp to sort data in ascending or descending order. The sort values function in Pandas data frames provides a number of options to sort, one of which is by parsed time. So we are getting the parsed time column in date format that we had before, and sorting time series data using the sort values function that's already a function of the data frame. Sorting time series data like this can help in improved and effective visualizations, because then you can provide a sorted data to your visualization. So we can say, in essence, Pandas' abilities to sort data based on timestamps can give us a big picture almost instantly. You can even look at this data set or data frame and see a progression over time by looking at, from above to the lower rows in the data frame. In summary, POSIX or Unix time can be hard to read for users because it's a large integer, but converting it to Python datetime format gives us practical ways to select the data and make it human readable in terms of timestamps, and create conditions on it using understandable timestamps from a human readability point of view. Let's now start our live coding session with the timestamps. As you know, any data with timestamps opens up enormous possibilities for insights, because when we know when that data was acquired, we can actually do a lot of generate a lot of understanding on that instance of time. So in this section, we want to explore Pandas' ability to see these timestamps and use these timestamps. If you remember, our original data set had some timestamps, but we removed those. So I'm going to reload that tags.csv into our tags data frame. And run the data types on it. Notice that this timestamp column is now being added. Right? Since we removed it initially, we weren't able to see it. But user ID, movie ID tag, timestamps were the original tab delimited or comma delimited values in this CSV file. Notice this is of type int64. However, humans don't think of time as an integer. We think of time as a month, date of the month, and time of the day, or rather as a combination of both. A very common format used by machines for storing time, as I mentioned in our overview, is the Unix time or epoch time. So here we see it in that original integer int64 value. Now we have to convert this integer number into a data type that Python can render as a date we understand. So what we do is we parse that to date time, and we'll call the new from tags timestamp with a unit s. That was the function also we overviewed. And we'll add that as a new column called parse time in our data frame. So when we look at that data type, it will now be M8. And if we get the top 5, we'll see that it's actually, Python knows how to render it as a year, month, day, and a 24-hour date format by default. We can tell this function to take a column as input, just to review, tags timestamp, and convert it into a date time. In this case, the format is M8, even though if it's a weird name, it's just a data type name. Notice that the new column, parse time, the timestamp, appears in a human readable way here. In contrast, the original timestamp was just an integer. Okay. Once we have converted the time to a human readable format, we can now create filters using timestamps we understand and select rows of interest. What's a timestamp we understand? For example, just a time, year, month, day format. Here we say greater than t. We are creating a filter. We are selecting that parse time from tags and checking if it's after or greater than this date. And then we'll create a new frame on this by applying the greater than t signal to our tags data frame. And we can see that initially in tags, there were about 465,000 rows with those 5 columns, user ID, move ID, tag, timestamp, parse time. And the selected rows has 12,000 something rows in it with the exact same columns. That means about 12,130 of those original 465,000 values were added after 2015, February 1st. We can also sort rows in chronological order so that the data flows from the beginning of time as it was recorded, and users can see the chronological order in this frame. So we'll say tags, our frame, sort values by parse time. Parse time was our new column here in ascending form, and give us the top 10 values in there. We could see that the original data started in 2005, and the time is growing from then. If you remember, 12,000 of that was after 2015. With this knowledge, you now have resources to tackle Unix timestamps in your data science projects. Let's now go back to our notebook, Pandas notebook, and see maybe average movie ratings over time. Are movie ratings related to the year of launch is a question you might answer, right? Here we have average ratings. If you would remember, this will be the average ratings frame, movie ID rating. For each movie, we had the averages. And then we can now merge this average rating with the movie ID and create a correlation value between movie ID and the rating. Now, we can create yearly averages by grouping by over year on that join table. We were joining it, and we have the years in there as well. If we select the top 5, we see the year of the movie and the ratings for that movie, but only based on the year. So now if we take a yearly average plot here, we'll see that some years look better for box office movies than others. But one year is particularly good. Does that seem like an outlier to you in some sense? Yes. And by really successfully combining everything we learned about filtering, about joining, about counting, averaging, adding new columns, we were able to really start generating that insight to analyze what years were better years to make movies, how they affected our ratings over time, and things like that. So I'll leave you with this graph to think of other ways to see correlations between those values and plot maybe different aspects, different features in our data set before we move on with a more advanced Pandas example in the next lesson. Hope you enjoyed this example. We will now have a small video to wrap up our lesson for Introduction to Pandas.